This is CPM Precalculus Chapter 2, number 160. So using rules of exponents and matching bases, solve the following equations. So that means we shouldn't just do the opposite every time. We should use the rules of exponents and matching bases. So let's go ahead and do that. Well, what is the square root? Let's go ahead and do each side separately for a few seconds. The square root is the same as the power of 1/2. So this is the same thing as x, 2 to the x inside, to the power of 1/2. Okay? And we know 4 has base 2 by making it 2 squared, right? 2 squared is equal to 4. So 2 squared to the power of x plus 1 is the same as what we have on the left, right? And the right, we're able to do this, just kind of simplifying, showing that the square root is the same as the power of 1/2. All right? So now let's go ahead and look at what this means. 2 squared to the power of x plus 1 is the same thing as 2 to the power of 2 times x plus 1, right? You can multiply these and then we have the same base. Similarly, we can multiply these exponents with the base of 2. So it's equal to 1/2 x in the exponent. Okay, we're just multiplying these and these. Now I see that we have a common base 2 in both parts. And we want to use the rules of exponents and matching bases to solve these equations. So we match the base. Both have base 2. So that means the exponents must be equal. So let's go ahead and do that step. 2 times x plus 1 has to equal 1/2 x, right? We're just looking at the exponents. And we set those equal because the bases are equal. The rest is just algebra. Let's distribute that 2, right? Let's subtract 1/2 x from both sides. We get 1 and 1/2 x here. Or we can write it as 3/2 or 1.5, either way. Plus 2 is equal to 0. Because we subtracted 1/2 x from both sides, let's subtract 2 from both sides. Divide both sides by 3/2. So x is equal to negative 2 over 3/2. And we know that's the same thing as negative 2 over 1, right? Times the reciprocal of that, 2/3, which is negative 4 over 3. Or if you put in your calculator, negative 1.33333333, right? Negative 4 over 3. So either way that you do this, you're going to get this answer equals to negative 1.333. Put a bar over that. So that's solving for x in part A. Right? Let's go on to part B. Part B, we want to do in the same way, but now we have 3 times 9 to the power of x and 27 to the power of x plus 1. So using the rules of exponents and matching bases, this tells me that I want the base of 3 everywhere, because I can reduce 9 to be 3 squared, right, to the power of x. 3 we know is 3 to the power of 1. 27 I know is 3 cubed, right? 3 times 3 times 3 is 27 to the power of x plus 1. And this is just making it so they all have base 3. To combine two terms like this, remember we want to add the exponents. So that's the same thing as 3 to the power of 1 plus 2x. 1 plus 2x as the exponent equals 2, and we can go ahead and write this as 3 to the power, and we multiply the exponents here. 3 times x plus 1. That's matching the bases. They both have base 3. And so we can go ahead and say 1 plus 2x, the exponent here, equals 3 times x plus 1, the exponent here. Now we're just going to do algebra, simple algebra to solve for x. So distribute the 3, 3x plus 3, 1 plus 2x on the left, right? Any way you want to do it, let's go ahead and subtract 1 from both sides. Subtract 3x from both sides. Divide both sides by negative 1, and we get x is equal to negative 2. Okay, this part right here is just some algebra. So go ahead and review this if you want to show additional work to get x is -2. More power to you. All right. So finally, let's go on to part C. We want to do it the same way. This time we have the cube root of 5 to the power of x equals 1/25 to the power of x minus 2. So this tells me I know that 5 squared is 25. So I want things in base 5, right? So let's go ahead and change this. I know the cube root means to the power of 1/3. So it's 5x here to the power of 1/3 is the cube root, right? And that's equal to 5, and we multiply these, so 1/3 x, right? That's on the left. Let's go ahead and do on the right. I can move this up by saying this is 25 to the power of 1, so moving it up means it's 25 to the power of -1, right? Still to the power of x minus 2. 25 I know is 5 squared. We just said that earlier. 5 squared to the power of -1 to the power of x minus 2. Now I just multiply all these because this is 5 to the power of -2 to the power of x minus 2, right? We still have 5 to the 1/3 x power here. -2 here we want to multiply until we get 5 to the power of -2 times x minus 2 equals to 5 to the power of 1/3 x. Finally, we have what they said, matching bases. So we can go ahead and say the exponents are equal. 1/3 x equals to -2 times x minus 2. Algebra to finish this off. -2x plus 4, distributing the -2. Right? Add 2x to both sides. Right? So we get, this is gone here. 2 and 1/3 x equals to 4. We can rewrite this as 2 we know is 6 over 3. So that's 7 over 3x equals 4. Or we can leave it this way and use our calculators. In fact, let's go ahead and leave it that way. Divide both sides by 2 and 1/3. We get x is equal to 4 divided by 2 and 1/3. Let's use our calculator. 4 divided by 2 and 1/3, remember it's 2 plus 1/3. And that's equal to 1.714 ... Right? So let's go ahead and show that we're approximating using approximation instead of equals. Oh, that doesn't look very well. There we go. Okay, so now I want to quickly do it and say, well, what if we made this 2 and 1/3 to be 7/3, right? Then we divide both sides by 7/3. We get x is equal to 4 over 7/3, which is equal to 4 times 3/7. That's over 1, which is 12 over 7 exactly. 12 over 7, right, should give us 1.714, right? So that's approximately 1.714285714, right? But approximately there, exactly equals there. So either one is okay, acceptable here. And we are done with CPM Precalculus Chapter 2, number 160.